Yes, you got a question?
On the computer test, will you like mark what we did wrong, or how will we know?
Okay, so let me say on the computer test, that's what I was actually doing during the quiz today. So just as a reminder for those of you who are watching this at home and are not here, okay, today is Tuesday, April 10th. I'm breaking my rules and I'm letting you guys do a redo on your tests. You have 1 week from today, so April 17th at 10 a.m. your rework on your test 3 is due. As a reminder, the rework on the written test, I want you to turn in your original test so that I can know what I marked wrong. And then on a separate sheet of paper, you're hopefully going to go through very neatly and explain how to do all those, and it's all or nothing credit, okay? You either get all the credit or you get none, and it's half credit you're getting back. So I've started letting you I'm going to give feedback on what you missed. That's what I was doing on the quiz today. Some of you have it, some of you don't. I will have that at the end of today, so you can know what you missed on the computer part, but you've got your written part that you can already start on, okay? Just redo the ones you missed. You don't need to redo the whole thing, just the ones you missed, okay? So you've got 1 week on that, okay? All right. Now, oh, I should have posted this. I apologize. Okay, I'll get this posted up today. All right, so chapter 18 is an outline of how to pick the correct statistical test. Okay, now having said that, the rules that I'm going to give you today apply to confidence intervals as well. Okay, confidence intervals and hypothesis tests, I think I mentioned this last time, are 2 ways to basically do the same thing. They're very different methods though. But the same assumptions that apply to hypothesis tests apply to statistical tests as well. Okay? Now, there are 7 questions, in fact, 7 questions. Okay, would you like to know what the test questions are going to be?
Yes.
I'm going to give you these 7 questions. These are the 7 questions, okay? These are the test questions. I may throw out 1 or 2, but these are the test questions, okay? How many teachers give you the test questions? Not very many, okay? These are the questions you will see on your computer exam, okay? And also a lot of them on your homework, okay? Question number 1, is the data quantitative or categorical? I won't give you the answers, but I'm going to give you the questions. Now, the answer is going to depend on every different scenario. Question number 2, find the null and the alternative hypothesis. Okay? Now that was the quiz we just took today. That was your homework you previously done. Hopefully that's an easy question to answer. Question number 3, pick the correct test statistic. Okay? Now, here's what I'm going to give you. I'm going to give you, there's 3 possible answers here. Okay? It could be a Z test, it could be a T test, and it could be a chi-square test. We haven't learned chi-square yet, but we're going to learn that before the end of the semester. Okay? Question number 4. Find a p-value, okay? And I'm going to add both the chart and Excel. There's 2 ways to find the p-value. You should be comfortable with both methods, okay? Either with the chart or Excel. Question 5 is compare to alpha. Okay? Now, a lot of times I forget to give you alpha. If not given, assume alpha equals 0.05. Now, by the way, remind me again, what's alpha? Remember what alpha is. Type 1 error, and I didn't give you any problems. I promised I was going to give them to you, so I'm going to give those to you before Thursday, okay? Because we're more concerned about alpha, which is the type 1 error, than we are about beta, okay? Number 6, decide whether to reject or not reject. Okay? And then question number 7 is to write, and maybe I should say reject the null hypothesis. Okay? Step number 7 is write conclusion in English, not statistician. And here's what I mean by that. Words that you should not use. Do not use the following words. Reject. Okay. Don't use hypothesis. Oh, and another word do not use is the word accept. Okay? Some people think, oh, the opposite of rejecting is accepting. I'm going to tell you today, accept just became a swear word. Okay? Sorry, I've been cussing in class. We're going to call that the A word, the other A word. Okay, we've got 2 A words. Okay? So don't use that word. Okay? Now, okay, so are you excited that you know the 7 questions I'm going to ask you on your computer test? Okay, you should really memorize those questions. Okay, they're going to be what you're going to, those are the questions I'm going to ask you. Okay, all right, so let me give you an example. We're going to focus on one type of test because I don't want to, so it'll be one of these tests here. We're going to focus on one of them. I don't want to give away the answer yet. Hopefully when we get to step number 3, by the way, let me just back up here. Step number 3 is probably the hardest step for students. It was also the step number 3 that you struggled with on your last test with confidence intervals, because the same principles that apply to step 3 here apply to confidence intervals as well. So hopefully, when we get through this, you'll be able to understand how do you decide when to pick a z, how do you decide when to pick a t, how do you decide when to pick a chi-square. Okay? All right. So let's do an example. You want to know if a friend is cheating while flipping a coin. Okay? You flip 10 times and get 7 heads. Okay? I think we kind of talked about this, but now we're going to run through the 7 steps to do a hypothesis test. So, and in fact, here's what I want to say about these 7 steps. If I give you a hypothesis test on the final exam and I don't give you these 7 questions, you should list them anyway to get full credit. Okay? Those 7 steps absolutely need to be memorized. Okay? Now, here's the other thing. For the rest of this semester, every class, we're going to go through these 7 steps. Okay? So hopefully this is like concrete in your brain. Okay? All right. So let's talk about this. Here's our example. You want to know if your friend is cheating while flipping a coin. You flip it 10 times and you get 7 heads. Okay? First question is the data categorical or quantitative? Let's vote and see how you guys do on this one. Who says it's categorical? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Who says it's quantitative? Nobody? Stephen, why do you think it's categorical?
Because there's 2 categories.
What are the 2 categories?
Yeah.
What are they?
Heads and tails.
Heads and tails, that is correct. Categorical is heads and tails. Oh, you know what? Okay. I'm gonna give you another outline as well. Oh, no, we'll get there. Never mind, we're good. Okay, question number 2. Find the null and the alternative hypothesis. Okay? So Amanda, can you give me the null hypothesis? P equals 7. Who agrees with Amanda? 1, 2, 3, 4. Who disagrees? Caleb, what do you think it is?
Should that be 5?
5?
5 out of 10.
So you,
Or is
5 or 5 out of 10?
0.5.
So you're saying P equals 0.5. Aaron, what do you think?
I was thinking 0.7, but not 0.5.
You were thinking it was 0.7. We got a multiple choice now. Anybody else think there's anything else it could be? Should we vote again? You got 3 choices now. Who agrees with Amanda that it's P equals 7? 1? Amanda, did you change your mind? You don't agree with yourself anymore? Who thinks it's P equals 0.5? 1, 2, 3, 4, 5? Is that a hand raised? No? Who thinks P equals 0.7? 1, 2. Okay. Who didn't vote?
Would it be 0.0?
Okay, we got some honest people. What did you say?
Would it be 0.07?
0.07? No, it wouldn't be that. That's the correct answer. Okay. Now, why is this answer clearly wrong? What'd you say?
It's not an fraction.
It's got to be less than 1, right? Between 0 and 1. The proportion is always between 0 and 1. Okay, so that's why that one's clearly wrong. Why is this one wrong? This was actually a good guess, but it was wrong.
So that's your data, but it's not what
It's your data. Is that P? It is useful information. We are going to use this in the problem. That's why it was a good wrong answer. What about, Ben?
That would be part of your alternate hypothesis.
No, that wouldn't be your alternative hypothesis.
Can you go through it without you asking questions and then ask us questions on the second example? Because if you're asking questions and I'm just like, I haven't learned this stuff yet.
But you have learned this stuff. Yeah. You had to do this in order to do if I had asked you to do a confidence interval, you would have known whether to use 0.5 or 0.7. Okay? That's actually P hat is 0.7. Okay? So yes, that's not correct either, but it is useful information that we are going to use later. Okay? All right, let's pick on Emily. What do you think the alternative hypothesis is? I think you know what the null is.
E is not equal.
Not equal. Why did you say not equal?
Two-tailed.
Because it's two-tailed, but why did you say it was two-tailed?
Isn't there only 50% chance that
Heads and tails.
Yeah, well, here's why. We didn't really define whether we're counting heads or tails, did we? So we didn't really define it. So here's what I will say. If you don't know, it's better to choose a two-tailed test than a one-tailed test. If we had defined this is the quantity of heads, you could argue that the P was greater than 0.7 or less than 0.7. But since we didn't really specify, go with the two-tailed test. Does that make sense? Yes, Lauren. Oh, not 0.7, you're right, it is 0.5.
Oh, yeah.
Sorry, I focused on the wrong thing. It should be 0.5. Thank you, Lauren. That's correct. It should be 0.5. It should be the same value you got here, you're going to use here again. Sorry. I was focusing on the wrong thing there, but yes. Okay, there was a question over there.
That was my question.
That was your question?
So, just to make sure I understand right, he said that if it doesn't specify which ones you got out of the heads and tails, we should do two tails.
Yeah, if you don't specify, you should do a two-tailed test.
But if it specified a certain one,
If it's specified a certain way, then you can use a one-tailed test, either greater than or less than. Okay? Yes, Emily.
I think that I don't understand where you're getting to that. But I think, I mean, I don't.
Okay, so let me ask you a question. If you were going to flip a coin 10 times, how many times would you expect that it would come up heads? Half the time.
3.5.
That's 1/2.
Perfect.
So when we're dealing
You
with,
could also, if you wanted to say, you could say P equals 1/2. That would be perfectly fine. That would
But you
be,
prefer decimal?
I don't prefer either way. Either way is 100% correct. Okay?
when we're dealing with categorical stuff, would it be like 0.5 most of the time?
No,
No, it's because there's only two categories that it's 0.5.
it's because there's only two categories. In fact,
So if we were rolling the dice, would we split it to 6?
Like I don't know how it would like figure it out, like head or tail.
hopefully we can get through these. We'll try to do another example where it's not 0.5, okay? All right, let's go on to step number 3 is pick the correct test. Now, I've given you here with my outline, is it a Z, is it a T, or is it a chi-squared? And oh, by the way, I'm not trying to rub this in, but you guys butchered this on the last test. Okay, so let's vote. Is it a Z? Who thinks it's a Z test? Nobody who thinks it's a T test? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Who thinks it's a chi-square test? 1. What'd you say?
I see. Just kind of think maybe it is a chi-square just because we haven't learned it yet. We're learning something new. So maybe
Right in my hand.
it's chi-square,
Yeah, that's
for sure.
exactly.
Chi-square, three chi-squares. Okay, so the answer is y'all got it wrong. It is a Z test. Why is that a Z? Okay, well, let me ask you a question. I know what you're going to tell me. A lot of you on that second to back row picked a T test. Why did you pick a T test? Because you don't know the population standard deviation, and I'm going to say that you do.
Where is it at?
It's not given directly, but you can figure it out. Okay? Now, having said that, okay, so, and this is, in fact, here's a clue. This is related to problem number 8 on your test. Okay? Same rule applies. Okay? You can find out your population standard deviation, even though it is, you're correct. You're correct in saying that it is not given to you directly, but you can figure it out. Okay? Now, there's 3 types of Z tests. No, there's only 2 for your class. Okay? The 2 equations that are on your formula sheet are P hat minus P over the square root of PQ divided by N. Okay, that's one. I'll call that A. The other one is Z equals X bar minus mu over sigma over the square root of N. Now, I could expand on the T. Do you want me to do that? Here, I'm going to do this. See, your t-test is going to be X bar minus mu over S over the square root of N. And I'll give you chi-squared later. We're not going to do that today. Okay? All right. So the answer is, really, we can narrow, because we know it's a z-test, which of those two equations am I going to pick? A. A because it's a proportion. And in fact, your standard deviation is the denominator right there. Okay? All right, now, so now that we know which test it is, so remember here it says pick the correct test statistic. Now we need to use this equation and we need to plug in all the information that we know. Now, in order to use this equation, okay, here's what I'm going to need to know. I'm going to need to know p hat, I'm going to need to know p, I'm going to need to know q, and I'm going to need to know n. You may want to get in the habit, especially on step number 3, of just listing out all of your variables and telling me what they are. So Aaron, what's p hat? 0.7, or 7 out of 10, right? 0.7. Does that make sense? We get that right from your experiment. You flip it 10 times, you got 7 heads. Okay? What's P Penzi? 0.5, where did you get 0.5 from? I can't hear you. It's right there. Where? What's this called? Null hypothesis, right? Okay. What's Q?
1 minus p hat.
1 minus P. Okay. So 1 minus 0.5 equals also 0.5. What's N in this case? N is 10. Okay. Now, I think this is a really good habit. If you can do this out and pick out all the information, that will really help you. Okay. So let's pick on Alex. Alex, can you help me plug this information into this equation? Yes, you can. Huh? Let me help you. Okay, I don't know what Z is, right? What's P hat? John will help you. What's P hat? Okay. What's P? So we're going to subtract 0.5. We're going to divide it by the square root of, what's P again? 0.5. What's Q? 0.5. See, I knew you could do this. What's N? N. See, I knew you could do that. Now, can you do it with both your calculator and with your computer? Here's the deal. Some of you messed up on your test because you didn't put parentheses there. Okay? That's a gotcha. Some of you used the right equation, but you didn't put parentheses in, so you got the wrong answer. Okay? Now, if I pull up Excel here, because it's easy to see and I can show people at home. Okay, plus if this is a computer test, this is what you're going to have to do. Okay? Now, a lot of times, one way to set this up is to do the numerator and to do the denominator. Okay. So the numerator is going to be 0.7 minus 0.5. Your denominator is going to be the square root of 0.5 times 0.5 divided by 10. Okay. I'm going to take my numerator, I'm going to divide by my denominator, and I'm going to get 1.26. So my z-score in this case equals 1.2649. Okay? So now I've finally finished step number 3. I've picked the correct test. In this case, it's a z-test, although I have 2 z equations, so I got to pick the right z. plug it in, I get Z equals 1.2649. Okay. Step number 4 is what, Hannah? What's step number 4?
Find the p-value
Find the p-value. How do you do that?
on the chart.
Okay. Now, before you look on your chart, let me add a hint to step number 4. The hint is WWRD. What would Rick do? Rick would draw a picture so that it doesn't mess up his p-value. Okay. Let's draw our picture here on the board so you can see my picture here. What is the mean of my picture? Jordan.
It's 7.
The mean is 7? No, it's not. What's your null hypothesis?
Okay.
0.5. So P equals 0.5. Okay. Essentially what we're doing here, okay, what value did I get in my experiment? I got a value of 0.7. So here's the idea. Here's what's going on. We know that if the coin is fair, and we always assume the coin is fair until evidence proves otherwise, that P should be 0.5. In our case, we got a P of 0.7. Okay? We're trying to decide if that is an unusual score. How do we decide if it's unusual?
Seeing how far it deviates from the.
Okay, yeah, how far it deviates from, yeah, we assume that it should be 0.5. But if the answer was 0.5 and I got 0.7, I really just want to find that area. That's what we refer to as our p-value here. I don't know why all my red markers are not very dark. Okay. Now the question is, how much area, what's the value of that area? Okay. Now normally I can't find that out without calculus, but if I convert it to a standard normal curve, I can do that. Now when I convert this to a standard normal curve, what is the mean now? 0, okay? So now I'm assuming that Z equals 0, right? So 0 corresponds to 0.5. What does 0.7 correspond to? This value I just found here, right? 1.26. So I'm 1.26 standard deviations to the right. I want to find this red area here. How do I find that? There's 2 ways. What are the 2 ways? With the chart or with Excel, okay? Now, Emily, you raise your hand.
I think that I was wondering where you got the 0, but you always have to have the 0 in a standard. Why did you get 0?
Why did I get the 0 here? Why did I get the 0 here? Because when I plugged it into this equation here, I converted it from a regular normal to a standard normal distribution. And the mean of a standard normal distribution is always 0, and the standard deviation of a standard normal distribution is always 1. So I'm a little bit more than 1 standard deviation away. Okay? All right, now I can do this both ways, either with the chart or with the Excel. Which way would you prefer? I'm going to pick on Ashley. You want to do it with Excel? Okay. Now, if we do it with Excel, does Excel give me the white area or the red area? White area. So I'm going to subtract it from 1, right? Okay, what's the command that I use? So this is my z-score. Okay, step 5 is the p-value. And I'm going to do equals 1 minus, what's the command, do you remember? Norm s dist. If you use the one without the periods, it's easier to use. And it's asking for the z-score. I'm going to put in that number there, okay? I get 0.102. So this area here in red is 0.102. Now, how would I find that on the chart? Okay, I'm going to open this up. The chart is right here. I've got an electronic version here. If I go to my normal distribution, how do I use this table? I'm going to find 1.26. 1.26 is column H here. So I got 0.8770, right? Oh, sorry, I'm in the wrong room. 0.8962. So it's going to be 1 minus 0.8962. Okay, does that make sense? So if I do that, so this is with Excel, with the chart, I get 1 minus 0.8962, and that gives me 0.1038. So it's off a little bit. Which one's more accurate? Excel's more accurate, but if you're using the chart, that's fine. Yes?
So on the steps on your questions, it says find the chart and Excel.
So-
if we're doing the computer test,
On the computer test, what are you going to use?
it's just-
Excel. On the paper test, you're going to use the chart.
So it's just depending on what you're doing. You don't necessarily want both. Like if we're doing Excel, you don't want to. split it up.
Yeah, so on the quiz on Thursday, what am I going to expect? The chart. On the test in a few weeks, what am I going to expect? On the computer test, I'm going to expect Excel.
But
Okay.
we're not going to get doctors who don't also use the chart on it.
You should not use the chart if you have Excel. Some of you did that, and I can't remember if I took off a point or not. I can't remember. I probably didn't because I was trying to be a nice grader, believe it or not. And I know some of you believe that's not, but I promise I was. Okay? All right. Now we're on to step number 5. Says compare to alpha. Now I didn't, oh, sorry, that was step 4. Oh, this was 4 was your p-value. 4 was your p-value. 5 is compare to alpha. And I didn't give you an alpha, so what do you assume the alpha is? 0.05. Now, would you like a good way to know? Okay, so we're going to compare, in this case, we're comparing 0.102 with alpha's 0.05. That's my p-value. This is my alpha. Okay? So, let me give you a wonderful phrase. It's not politically correct, but it does help you remember. Okay? You guys will laugh at this phrase, I hope. Okay? So, when you're comparing it to alpha, you're going to decide whether to reject or to not reject. Okay? Here's the phrase that pays. If the p-value is low, reject the O. Okay, or the null hypothesis. Okay. Now, let's go over here. We've got a p-value of 0.102. Is that lower than my alpha? Okay, so do I reject or do I not reject? Who thinks we reject? Who thinks we do not reject? 1, 2, 3, 4, 5, 6, 7. There's a lot more than 7 people in here. Yes, the correct answer is do not reject. Okay? Now, what we mean is we do not reject the null hypothesis. We therefore think the null hypothesis is true. The null hypothesis, in conclusion, states, and so when I say, so the step 7 is, so really there's nothing to do on step number 5. You're just comparing it to alpha in order to decide whether to reject or to not reject. Okay, so you don't remember that, but it really is step 6, okay? Write the conclusion in English. Now the conclusion in English, you want to know if your friend is cheating. Is your friend cheating according to this experiment? No. So your conclusion there is not enough evidence that the friend is cheating. Okay? Now your friend could be cheating. You could be making a type 1 error. You won't probably want to keep them as friends, right? Except for Caleb. He's like, no. When money's involved, you're not a friend anymore. Okay? But does that make sense? Okay? So you reject or you do not reject, you never use the A word. Okay? Don't let me see that on your homework.
Interesting not to use the word reject.
So on step 6, you can use reject or do not reject. Step 7, I don't want you to use reject.
So we can't use that word in our.
In your conclusion. I don't want to hear anything about your null hypothesis or rejecting or not rejecting or the A word. Okay? So tie it back to the question here. What's the question asking? Okay. So now that you've seen this done once, we're going to do another one where the P does not equal 0.5. And we're going to do it fast because we've only got 7 minutes left. Okay? So here's the example. And I'm going to try to keep your homework fairly easy on this. Okay? I'm going to keep. Oh, I shouldn't have erased that. Sorry. That's all right. I don't want to erase that either. Okay, so here's the new example. Okay. Prevnar vaccine was administered to 710 patients, infants, okay. 121 had loss of appetite as a side effect. Other vaccines show 13.5% with loss of appetite. Is there evidence of a difference use alpha equal 0.01? Okay. First question is, are the data categorical quantitative? Okay. How many vote quantitative? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to say categorical. Nobody? Everybody got it wrong again. It's categorical. What are the categories? How do you know this is categorical? They either have a loss of appetite or they do not. Okay? What's a good key giveaway that this is categorical? This percentage. Now, is percentage always correct? No. But when you think about a loss of appetite, what are the lowest and highest values it can be? 0 to 100%. Is this a proportion? Yes. You can't go more than 100%. You can't go less than 0, right? You can't have less than 0% of infants have a loss of appetite. Okay? Okay, so we've got to, if you miss that step, you're screwed the rest of the way. Not to put any pressure on you or anything. Okay? Do you want me to give you a hint? Today's homework, that I haven't posted yet, but I will, is all categorical. Okay? We're going to try to focus on one equation today. We'll use another one on Thursday, probably. Okay? All right, so it's going to be categorical. Now that we know it's categorical, what is the null hypothesis? Who haven't I picked on? Gabrielle.
Yeah.
What do you think the null hypothesis is?
Percentage.
Okay, so tell me what to write.
P equals 13.5.
So write it as a decimal, 0.135.
Okay.
Okay? Leave it as decimal, 0.135. The alternative hypothesis is, John,
P equals sign? No.
what'd you say?
P is not equal to 1, 0.135.
P does not equal 0.135. Why did you say not equal to?
Because it's detail.
Because is there evidence of a difference? It doesn't tell you if it's better or worse, right? Okay, and plus, if we don't know, not equal to is the better answer. Okay? Is it a z, a t, or a chi-squared? Who says z? 1, 2. Who says 3? Who says t? 1. Who says chi-squared?
I'm going to say Z.
1, 2. You can't vote. You only vote once.
I'm saying Z.
Okay, it's a z because all of your homework problems tonight are going to use the same equation. Okay, this is the equation. But having said that, I'm not going to give this away on the test. Okay, you've got to decide, okay, if it's categorical, it's always going to be p hat minus p over the square root of pq over n. If it's quantitative, you're going to use this one or this one, the t equals. Okay? How do you decide between the z equals and the t equals when it's quantitative? Do you know the population standard deviation? Do you know the population standard deviation here? No, but you can figure it out, right? Okay? Now, what's the p in this case? What's the p hat? What's the q? What's the n? Real quickly, let's go with Sydney. What's the p?
0.135.
What's the p hat? Just tell me what it is. You don't have to calculate it. 121 divided by 710, right? What's the q? 1 minus 0.135. And what's the n? 710. Okay? Now, there's only two categories. Are these equally, are they equally likely categories, like a coin flip? No, not at all, right? This is a definitely biased coin. Okay, it's biased in the good way. We don't want our kids getting lots of appetite. Okay, so Aaron, can you punch this through for me? Tell me what's right here. Z equals?
Wait, so I would do all of it together, right?
Z equals p hat. What's p hat? 121 over 710. Just write it like it is, okay? What's p? 0.135 divided by the square root of 0.135 times 0.865 divided by 710. Okay, so we're going to punch that through really quick. Here, we'll pull up a new sheet here. So your numerator is 121 divided by 710 minus 0.135. Your denominator equals the square root of 0.135 times 1 minus 0.135 divided by 710. We're going to take this divided by that. Okay, that gives me 2.76. What's the next step? Find the p-value. What's the key phrase on the p-value? What would Rick do? Rick would draw a picture. You should always, whenever you're doing this, draw a picture. My picture, the mean, if it's a standard normal, the mean is? 0. How many standard deviations am I away? 2.76. Okay. So if I'm using the computer, it's going to be a 1 minus norm s dist, right? 2.76. That gives me 0.002. This area here is 0.0028, right? Yeah, I think so. I'm going to compare to alpha. What's my alpha? 0.01. Is my p-value lower than my alpha? Yes. So reject or do not reject? Reject the null. Okay. So we no longer believe that the null is true. Therefore, what do we believe? We believe the alternative is true. Now, it might be nice to know, what is 121 divided by 710? 121 divided by 710 is 17%. Okay? My p hat here works out to be 0.17. Is it better than the old vaccine, or is it worse? It's worse. More infants have loss of appetite. Okay, so we said reject. Okay. So therefore, what's your conclusion? Your conclusion there is evidence that more infants have loss of appetite with Prevnar. You may say it's more unsafe because we don't like our infants having loss of appetite. Correct? Okay, does that make sense? Okay, homework is going to be due Thursday. I'm going to throw some type 2 stuff on there because I forgot to do that on the last test. Type 1 and type 2. And we'll do this as well.
I just have a question.
Okay, let me stop recording.